All right. Yeah, for sure. 1 second. So my project for this year is the squirrel chasing robot, and I'm Leo, and I'm going to be a junior at Monte Vista High School. Uh, I guess first, like we can look at a demo video. So basically, I built a robot and it will turn, and while it's turning, it will attempt to identify the squirrel. And the moment it will continue turning until it identifies the squirrel. And when it actually identifies the squirrel, it will drive forward to scare away the squirrel, hopefully. Right here, I'm using a toy squirrel, so it wouldn't do the same effect if it's in real life, but uh, oh, let's see what happens, I guess. So right here, the squirrel's right in front of the robot. So it will drive forward and yeah, crash into a squirrel. Not the greatest idea. All right, so my base project. I actually did my base project like during the second week, but it's basically a tracked robot. I wanted to track the squirrels. That's why I have this chassis. And I have a lot of squirrels in the backyard, and they are getting pretty active. So I thought that a robot that drives around and can scare the squirrels away would do them good. And now for the modifications I did on top of the chassis, I used the machine learning model. It's called NanoNet to identify the squirrels. I can get the video feed from the camera, send it to the online model, and then read the results from it. Some of the results are like the percentage denoting the likelihood that I detected a squirrel or not. And it'll also give the coordinates. And the coordinates allow me to draw the box around the actual squirrel. I think the picture shows that. So now for some challenges. So I had to deal with 2 motors to power my tank. And there were no documentations on these. So that made it really confusing. And I tried to look into data sheets. So that kind of taught me how to deal with DC motors. So I basically ignored the Hall sensor wires and I focused on the 2 power wires for the motors. And it turns out that it actually works without the Hall sensor wires, which is really nice. I drew a circuit diagram and also made a 3D model of the tank, and both of them helped me to overcome the challenge. For the lesson, I guess even though it was quite hard, my favorite aspect from this project is making the robot can be controlled, and I can drive it around using keyboard commands. And I also watch it like I also navigated it through some obstacles, and I see that it's very sorry, very powerful because it has tank tracks. So it took a long time for me to wire everything together and find enough battery to power the thing, but it was really cool. And yeah, I learned a lot about electrical engineering. So I guess that's a new field for me, and as well as a lot of programming. And it's kind of interesting to do coding for my robot. All right, I think that's it. Oh yeah, any questions?
I have a question. So you made that 3D model in that circuit diagram yourself?
I think I used an app, but I have to connect every component together. And if you're talking about the 3D model, it's this one. That's the 3D model I made. Yeah, I had to put all the components together, and I kind of just followed my 3D model to build my tank.
It's very impressive.
Thank you.
All right, well, if there's no more questions, everyone, let's give Leo a hand.